Hello everyone. I offer a hearty welcome to all who are present today. On this day, we are celebrating the 150th birth anniversary of Professor S.P Chatterjee by organizing a special memorial lecture on geospatial technology in glacier management. Professor S.P Chatterjee was the head of the Department of Geography, University of Calcutta. He was also the founder director of National Atlas and Thematic Mapping Organization in the Government of India. He was awarded with Padma Bhushan in 1985. Now I'll ask our convener, Mr. Shobhit Shah, Assistant Professor in Geoinformatics, IIGST, to address us.
Thank you, Hia. Unmute yourself. Was unmute? Welcome, sir. Thank you everyone. Today's webinar topic is geospatial technology. Geospatial technology in glacial management. So this topic is most important nowadays. Hence, I would like to welcome our guest, our chief guest, sir, Dr. Rajiv Mahajan, sir, scientist G and advisor, Science and Engineering Research Board, Ministry of Science and Technology, Government of India, New Delhi. And now next, our distinguished speaker, Professor R.B. Kayastha, sir, Kathmandu University, Nepal. And now next, Dr. Bajpai, madam, Assistant Professor, the Maharaja University of Baroda, Gujarat. And another guest is our Professor Avtar, sir, Hokkaido University of Japan. So today's webinar on geospatial technology is the glacier management, because glacier and glacial lakes are generally located in remote areas where access is through the tough and difficult terrain. So creating inventories and monitoring the glacial lakes can be done quickly and correctly using the satellite images and aerial photographs. And also visual and digital image analysis techniques integrated with GIS are very useful for the study of glacier and glacial lakes. So satellite remote sensing offers several unique advantages: a quick data collection, reliability, more accurate and repetitive collection, geometric integrity, and mapping, inventory, and monitoring the natural resources. So this webinar will be highly effective on effective policy making, future planning, and sustainable development, and etc. So thank you all, our chief guest and all my other participants and our chairman, sirs, and everyone. So now here I over to you to continue the session.
Unfortunately, Dr. Rajiv Mahajan could not be present with us due to unavoidable circumstances. So I'll ask Professor R.B. Kayastha to please deliver his speech.
Okay, thank you. Thank you. Yeah. Sir, unmute yourself, sir, please.
First, unmute. Now, can you see my slides?
Yes, sir.
Okay, good then. Okay, let's start without delaying any further, because I have to leave soon. So first of all, I would like to thank SAIARD for giving me this opportunity to say something about this geospatial technology in cryosphere studies as a special memorial lecture series of SAIARD. I think this is my maybe the third such webinar. Very fortunate to give in this SAIARD's different activities. So I'm currently heading the Himalayan Cryosphere Climate and Disaster Research Center. Therefore, the title is exactly matched what we are doing in our center, Himalayan Cryosphere Climate and Disaster Research Center. In short, we call HICCDRC. as you have said, that geospatial technology and cryosphere are very linked. And nowadays, due to this advancement of technology and availability of technology, so this geospatial technology are very useful in cryosphere studies. Therefore, we are using much nowadays. As you said, cryosphere regions are located in very remote, inaccessible highlands, mostly in case of Himalayas, except in the other cryosphere, which are very near to the sea. And those cryospheric components are lying at difficult terrains. So due to this, nowadays the cryospheric studies are very easy to study compared to 10 years or 20 years before. And nowadays we are using a different geospatial technologies to monitor and study the field of cryospheric sciences. And currently we are using these different geospatial technologies like DEM, satellite remote sensing, plus altimetry also, not only images, altimeters or the depth or the elevation changes are also being used. And the next one is unmanned aerial vehicles, UAV, or in short, we can also call as a drone, and DGPS. So these 4 components we are at our high CCTRC at Kathmandu University, we are using for different glaciological studies. So first I will show you a geodetic or the dam differencing methods for surface elevation change. So here what we have done is we have used 2 dam, one in 1970. So the Corona dam was obtained from 1970, and this High Mountain Asia dam 2013. So when we compare these 2 dams, then we will get the elevation difference, and from that elevation difference, what we can conclude that how much mass of ice was wasted, or how the surface loading is occurring on those different glaciers. So we can see here the much of the glacier in the lower part has decreased its thickness, or the loading was higher at lower part of the glacier compared to the higher part, because in the higher part there will be some accumulation. So this was our recent study, recent evolution of glacier in the Manaslu region of Nepal from satellite imagery and UAV data. So UAV data also we have carried out. I will show you next. So these are the different satellite images, as we all know, currently using much in the field of cryosphere. And now, like these also, so we can use the satellite images and satellite data, how the glacier lakes are expanding, and at the same time, how the glaciers are shrinking. So once the glacier lakes enlarge, then at the same time, glaciers will be decrease its length. Not only length, before we have already said that due to the dam difference, we can find out the surface loading. So surface loading as well as the change in its the retreating of glaciers, we can find out using such satellite navigation systems. Nowadays, we can use Google Earth Engine also for such data. So these are the different glacier lakes: Tulagi, Chorolpa, Imja, Lower Barun, Tampukri, and this is Lumdingcho, like that. So these are the 6 most largest glacier lakes of Nepal. And not only the glacier lake and glacier change, we can also use the satellite data in order to find out how the glacier ice is moving. So here, this is a Gozumpa Glacier in Khumbu region. At the higher parts, we can see along those lines, red lines, and these red lines are concentrated here. And as we go down, those red lines are sparse and less. So these lines represents its velocity. So at the higher elevations, the ice flow will be high, means the velocity will be higher at the higher elevation, and as we go down, it will reduce. So from this, for this, I think we have to use the how the surface on the glacier points changes as time passes. So for example, if we have 2000 image and 2005 image, so on those two images, we will find out the common point, and if that point moves, then we will calculate the velocity. So based on that, we can estimate the velocities, and if we have all velocities, then we can get the average velocity of the glacier at different locations. And the next one is comparison of melt from the glacial hydrological degree day model GDM and RS data, remote sensing data SCAT. So this is about how we can find out the glacier, whether the glacier is melting or it's freezing, thawing or freezing. So here the red dots are the melting parts on the glacier. So this is a glacier river basins of Nepal, Trishuli river basins. Red are melt and blue squares are not melting, freezing we can say. And this we can get from the RS data. And these red dots are determined from this one. So this is about our glacial hydrological degree day model, which we have developed at ICCDRC KU. So here we need the temperature, precipitation, and land use type, degree day factors. So after giving these all input parameters, then we will get, by running this glacial hydrological GTM model, snow melt, ice melt, rainfall, base flow as a simulated discharge. So this river discharge we can separate into 4 components, which will be very useful for different analysis. And this data, snow melt and ice melt, we have used to find out these red dots. Then we compare with the SCAT, which is the remote sensing data. Then we found that it is very much matched, more than 70%. So this is the SCAT data. So here the red means the melting and the blue are the thawing. So from this, we generated this one. So in this way, we can also use this remote sensing SCAT data. SCAT means is radio scat, advanced scatterometer data, which will give us whether the surface is freezing or thawing. And thawing we will compare with the GDM data. And next, so this is also the same, the special distribution of glacier melting from the SCAT and GDM. This was published in 2020 in the Frontiers of Earth Science. So these points are the melting points, and we can say this is from the SCAT and this is from the GDM. So here it matches quite well. Therefore, the estimation of glacier melt by GDM matched with SCAT data. So in this way also we can use the remote sensing data for glacier studies. And now we have also used the unmanned aerial vehicles, UAV, for the study of Pongkor Glacier. And this was first carried out in March and July 2016. Initially, we have, this was the first time in Nepal. So we have used the quadcopter, and we didn't take generator. So the battery was limited. Therefore, we have carried out only spotted like these 3 places. And next in July, we took the many batteries, extra batteries, as well as the generator, so that we can perform the long survey up to here. And this, from these 2 surveys, we found that this glacier was retreated from this 20 March to 5 July 2016 are 94 centimeter and 68 centimeter. And these represents to 0.88 and 0.65 centimeter per day, respectively, at 2 debris thicknesses. 11 debris thickness, 11 centimeter and 20 centimeter. Because if we have a debris on the clean ice, then those debris will retard the melting. So higher the debris thickness, lower will be the melting. Therefore, at higher debris thickness, 20 centimeter, this melting was lower, 0.64 centimeter per day. So in this way also, we can use this UAV data for glaciological study. And we have also used the same glacier with fixed wing UAV. Then we covered the whole much larger area than the quadcopter before, and this was carried out in 2018. So the whole most of the glacier part is covered here, and from this UAV data we can also generate this digital surface model of DEM of the glacier. And if we have two DEMs of 5 years difference, then by comparing those two DEMs, we will be able to know how the surface is loading of that glacier. So in this way, we are using UAV for glacier loading study of the Sponkor Glacier in Manaslu region. And this is about the bed map study. Means first we will know how thick the debris, the ice on glacier. So here we have studied this Gozumpa Glacier in Khumbu, and using this airborne ice sounding radar. This is very similar to the GPR, ground penetrating radar, but not on the ground. It is airborne, means we have to carry that radar on the helicopters. So we have carried out this study in Gozumpa Glacier in Khumbu region, and like this. This was carried out in 2018 from the British Antarctic Survey scientists. We together did this one, and we found that the thickness of the ice on those the survey lines like these 200, 300 meter depth, we can find out by such surveys also. So in this way, we can use the different aerial geospatial technologies for the glacier study. And not only that, repeated DGPS studies on Yala Glacier in Langtang also carried out in from 2009. Still, we have, I think, maybe 2018-19 up to 2019-18, and we have the DGPS data up to 2015. So if we have DGPS data of 2009 and 15, then by comparing these two GPS surveys, DGPS surveys, altitude difference, then we will be able to know how much ice was thinned on those lines of survey. So from that, what we will know, how much ice was lost on those survey points. So with that, we will be able to know how much ice was lost and what will be the implications in future if that rate of ice melting or the lowering of surface continues, what will happen in 10 years, 20 years, and 50 years, and so on. So these are the different geospatial and technologies we are using at present at Kathmandu University. I think the such studies are using not only in Nepal, Himalayas, and in India, in Pakistan, and in many other glaciers worldwide also. Not only small glaciers in Antarctica, Greenland also, they are using the very similar one, but in those ice sheets, they use the airborne or the satellite altimetry in order to find out how the ice is loading on those ice sheets. So these are the main ones. I think I have completed my presentation. Thank you very much for your kind attention.
Thank you, sir. Your lecture was quite enlightening. We appreciate you being here. Now I'd like to ask Dr. V. Bajpai to please deliver your lecture.
Good afternoon, everyone. Am I audible?
Yes.
Sir's lecture was too enlightening. I feel really small in front of him to present my lecture. But then also I'll try to fit in his boots. And there's a lot to learn from all of you here, because this is my first lecture with SAIARD, and I just completed my PhD in glaciers. And right now I'm working in the Maharaja Sayajirao University of Baroda as assistant professor. So I'll like to proceed with my presentation. So I would like to start. The topic of today's presentation, the lecture is the use of geospatial technology in glacier monitoring. Um, so basically, I have been, because this is my PhD topic and I have been doing this from last 10 years or so. So I have whatever knowledge I have that I would like to put in front of everybody. Uh, Basically, we have a planet. Our planet is blue. Why? Because 70% of the world is covered by water, and 10% of the land is occupied by the snow and ice. And there is about a lot of ice here. That is approximately 30 million cubic kilometers of ice on a planet, which covers approximately 10% of the world's land area. So here in pink in the background, you can see all those pink areas are the glaciated area, and the white is the snow, perpetual snow. So basically, the glaciers contain about 69% of the world's freshwater resources, and it is estimated that if all the ice melts and the global sea level will increase about 70 meters, that is 230 feet. So this is approximated by NSIDC into 2020. And it is also said that outside of Antarctica and Greenland, the largest glacial belt is in our Himalayas, in the Himalayas, which covers about 6 countries. So it is in the Himalayas, which covers about 15% of the land area. I would like to start with the basic that what is glacier and why do we and how do we study glaciers? So glaciers, as all the dignitaries here are very well, they know it very well that it is a mass of snow and ice and moving debris moving on land under the influence of gravity, and it has a slightly reduced density from ice uh, formed from the direct freezing of water. And plus here, as you can see, this blue tint, this is because of the slight absorption of the red light and due to the overtone of the infrared. So this is an aster image, which we are seeing in here. So as everybody is here is well versed that how a glacier looks like, but again I would say that this is the highest part, which is the glacier accumulation, followed by the glacier ablation area, followed by the snout and the outlet stream. So this is how a glacier looks like in a book. Until we studied from school onwards, we have been studying how a glacier looks like. But in reality, when we go to the glacier and on the image, it is totally different. So why are we all talking about glaciers? This is the major cause here. The minutest of change is noted by the glaciers. So the mountain glaciers are said to be very sensitive indicators of change of temperature and precipitation. And they provide direct information on climate change. And plus the paleoclimatic inferences can also be taken, and they can be carved out if we know about the present glaciers also. Now let me take you to the Himalayas, because from all of us here are very well versed with the Himalayas instead of the glaciers outside the Himalayas, because we have been studying Himalayas from our childhood onwards. We know the Himalayas. What are they, and a little bit about them. So as you can see, the white patch here is showing the length of the Himalayas, which is approximately 2,500 kilometers, and a width of 240 to 330 kilometers, covering India, Pakistan, Bhutan, Nepal, China, and Afghanistan in it. And outside the polar region, Himalayas is also called the third pole, because outside the polar region, Himalayas has the maximum concentration of glaciers. And approximately in 33,000 square kilometers of the Himalaya cover, this is the area which the Himalaya covers, and 30-40% additionally being the beyond, which is covered with the snow. So this is the three divisions, the Indus, Ganga, and the Brahmaputra, three major sub-basins of the rivers which flow from the Himalayas, and in them only are the major glaciers. Here, the whole wide portion here you are seeing is the glaciers. And above that, but we are here concentrating on the Himalayas, of course. So, quantifying the glaciers, the glacier borders and the associated elements were shown as rough outlines in the early 17th century. So this is not now that we are studying about the glaciers. From the early 17th century, people have been very interested in about the glaciers, because from then people have got the knowledge that glaciers is something which is telling us about the climate change. So Survey of India has been taken India's primary agency for surveying the Himalayan mountain range. And Survey of India released a topographical Himalayan glacial landscape at a scale of 1:50,000 in 1960, based on the aerial photographs and minimal fieldwork. Fieldwork here, as all of us know, is practically impossible because of the rugged terrain. We cannot reach to each and every glacier. That is why geospatial techniques came into being. We are every day developing new and new geospatial techniques and improving ourselves. So by Rena and Shrivastava 2008, they introduced the glacier inventory, and they have done the historical documentation of the glaciology and the few glaciers. So back in 2008, it was said that this is what is a glacier inventory. So like earlier glacier inventories were like the World Glacier Inventory, which contained information about 130,000 glaciers, including parameters like the geographic location, where it is located, the orientation, the length, elevation. Similarly, the Chinese Glacier Inventory, and ICMOD, which they are repositories of huge database. But and like in India, the Indian Himalayas, Bhuj and Kulkarni and Krishna Dobal, and these have been the premier people in marking they have the premier works in glacier inventory. So, and they have started using Landsat and different with the topographical maps and with the basic data. They have been started using this data and making the glacier inventories. So now, how do we identify a glacier on a satellite imagery? On a book we saw earlier, how does a glacier looks like? But on a satellite imagery, how do we identify that? So through the SWIR band, that the shortwave infrared, that it absorbs the snow and reflects the cloud. So we use the false color composite, basically, with a band combination of 2, 3, 5, whatever band suits us. The better the satellite imagery, the better the bands, and multi-day data is also taken. So the tone, texture, association, which are the basics of this thing, remote sensing. With those we identify the glacier. And the snout is basically we identify with the help of a shadow area or a stream flowing from there. So this is how a glacier looks like in a Landsat image. Here you're seeing. So this is how this blue portion, the cyan portion, is all glacier with a band combination of 3, 4, and 5. And without changing the band combination, the AWIPS data, here you can see white is also, the glacier is also white and the cloud is also white. Hence, we change the band combination to the false color composite, and now we can see, of course, these are two different data. But again, if I convert the same data in the false color composite, the glaciers can be seen. So this is how a glacier looks like on a satellite imagery. So I've got a chance to work with Space Application Center. I've worked there for 5 years. So there I've been a part of the glacier inventory, Himalayan glacier inventory. So there we have, because we can't take any glacier and digitize it or make an inventory out of it just like that. So we need to identify the areas where they are. So for that, we divided the whole area into small sheets of 1:50K, and approximately the whole Himalayas covered 1:75 sheets. The whole Himalayan glaciers were covered in 1:75 sheets. And this was overlain by the SRTM DEM data. So very well, as we saw in earlier also, this is how a glacier looks like. And these are the different areas. Like this is the ablation area. And this is the small dust, the small rugged area is the debris covered area. Okay. And this is the lateral moraine, as you can see here. These are the accumulation area of the glacier. And from where the stream is starting, here is the snout. So we have to use our association and the tone, texture, all this in identifying the glacier. So basically, after identifying the glaciers in a glacier inventory, we are using the polygon features, different point, polygon, and line features to make a glacier. So we demarcate the glacier boundary, the accumulation area, ablation area, the moraine dam lakes, the supraglacial lake, the deglaciated valley, and in the point feature, the highest and the lowest elevation points and the snouts, and in the line features, the equilibrium line and the ice divide line. So these are the steps which I am showing how to delineate a glacier. So when you see a glacier like this, so the drainage line and is delineated. This is the river which is delineated. Then this is the snow-covered area which is delineated, and then we delineate the glacier boundary. After that, after the glacial boundary is delineated, the accumulation area, which is in green, here you can see. Then the orange portion is the accumulation, ablation area, I'm sorry. And the red points here are the snout, or the lowest point from where the glacier, the stream starts, the lowest point of the glacier. So here we are marking the ice divide line and the snow line, and the ice divide line here we are marking here. And finally, this is how a glacier data sheet looks like. So when we divide everything, this glacier is divided, the same things you can see here. This is the snout area. Here you can see the snout area. This is the ablation area, debris covered. This in cyan dots. This blue portion is the accumulation area. Okay, so one by one, we delineated each and every point, line, and polygon, and finally delineated and finally marked a glacier. So this is the final glacier inventory map of Sikkim, one of the parts of Sikkim, which I've done. On ground, then again, I went on the ground and I was amazed that it doesn't look like the book or the satellite image. So it looks something like this. This was the lateral moraine. This was the valley surface striations. This was the accumulation area. This was the ablation area. So it looked nothing like anything like on the image and in the books, which we used to understand. So this is one of the sample glacier inventory data sheet, which see here we are giving, because we had already divided the whole Himalayas in different glacier data, the small 50K data sheet. So each one is given a number according to the topo sheets at 78A. So so the GLAC ID of the glacier, again, there is a unique ID. This ID is unique ID for each glacier. So like this, we had entered all the data, the length of the glacier, the width of the glacier, the minimum width, the form, the class, the ablation area, accumulation area, everything. So now this data has been uploaded in the Himalayan Glacier Information System. And there you can click, and if you go and in Vedas SAC, so you go there and you can again click there and see the information of each and every glacier, whatever we had entered in the previous glacier data sheet. So here you can see the divisions which we had made earlier. All these divisions can be seen here very clearly. And I also tried automatic glacier extraction, which did not go well, because the data I was using of AWIFS and Landsat and not very fine data I was using. So this is how I delineated the glacier manually, and this is how I delineated it automatically through the DEM, with the help of DEM. So this is showing the highest point. this point is showing the highest point, and this is the lowest, or the snout. So, but it did not go well, and it did not. I could not uh, use the automatic extraction in digitizing the glaciers. So I had to do it manually. So why are we doing all this? There must be a reason for this. One of the reason is, like, if we have all this data, so we can connect it with the village or the nearby city, whether what effect the city, the carbon soot, now how much effect it has on the glacier, how near it is to the glacier, how near is that settlement to the glacier. So here, like 2.65 kilometers, it is a distance. Lachung is at a distance of 2.65 kilometers from this glacier, and Lachung, from this glacier, Lachung again is at 3.51 kilometers. So now, further studies, we can always do the further studies, that how far it would affect that glacier, and any anthropogenic activity in Lachung, how will it affect in that glacier. Similarly, in Lachen, we have taken three glaciers were quite near, which were under 3 kilometers, 2.64, 2.89, and 2.54 kilometers. So again, we can further study that how do these anthropogenic activities in Lachen and Lachung in Sikkim affect the glacier. So we also are studying nowadays the lakes, the glacial lakes. Why do we need to study the glacial lakes along with the glaciers? So basically, there is a fast retreat during the past decade. It has been seen that rapid, because and the moraine dam lakes have been retreating. The glaciers are retreating, and the increasing potential energy is decreasing the strength of the damming material, and so this loose moraine can be breached anytime, because Himalayas are seismically active zone. So this any event can cause a glacial lake outburst flood, because the damming is not very strong. So here I've tried, I've just given nomenclatures of 1, 2, 3 instead of giving the names of the glacier, of the lakes. So I've marked 3 lakes here in Sikkim, the moraine dam lakes. And so I have done temporal study of these 3 glacier, these 3 moraine dam lakes from year 2000 to 2021. And significant change in the size has been seen in from 1.58 square kilometers in area to 1.70 square kilometers. So it has increased in area. So the glacier has also melted. What this data shows, the glacier has melted, and the moraine dam lake has increased in size. So from that, with many layers attached, with many the slope, all the other data, the profile of that area, the slope, and other data input, I have come up with this glacier lake outburst flood hazard zonation map for Sikkim. These 3 glacier lakes. These 2 lakes are in the very high zone, very high danger zone, and this one is lies in the high danger zone. So with what to do with this? Again, a question arises. So with this, again, when we trace this data back to the settlements, so we now measure the distance. Now, where do the settlements lie? Do they lie in their way or not? How close are they, or how far are they? If these glacial lakes burst at some point of time, which area would be affected? So now all these villages have been marked just for that reason. So if at all any of these 3 glacial lakes, moraine dam lakes, burst at some point of time, so what is the valley profile? What kind of slope is there? What is the valley shape? So everything is there. We have the data. So when we know that now at what rate how much water is there in the lake, the volume also we have calculated. So how much water is there, when we know everything, so we can know that when will the water reach at Hema and Lachen and so on, whether it will reach, or it will in the way only it will flood out here and it will not reach Hema at all. So through this, we have to see the usability of the data we are creating. So the way forward is the automatic extraction of the glacier feature. So the manual delineation task would be, it is too much to do. So, and there are certain human errors which we are integrating with that. So for that, we have to use high resolution data and multi-sensor data for more accurate delineation. And plus the black carbon soot measurements should be done. And glaciers are not melting every now and then. In a decade, in 2 decades or so, the glaciers do melt. Otherwise, it is not that we are going through climate change every day. So definitely they are very sensitive indicators. They're very sensitive to climate change. So we can if we study one glacier, so we can understand how dangerous or how good it is for us humans, and the health of the glacier can be assessed through that. And these are some of the field photos which I visited. Thank you, everybody, for your kind attention.
Thank you, ma'am, for the splendid presentation. And we'll be dividing our interactive session into 2 halves, as some of you might have prior commitments scheduled on around this time. So if you have any questions for Professor Bajpai, please raise your hand. Yes, Mr. Waisur Rahman, please, you may ask your question.
Thank you, ma'am, for giving me the opportunity to ask the questions. Whatever the slide that professors have shown, this is fantastic, and I'm really amazed by seeing all these slides, ma'am. Ma'am, I have questions to you, ma'am. If I want to measure the snow surface temperature, then what would be the process? Like, I have done something, and in fact, my topic is also like I want to predict the snow albedo using deep learning. So I have been working since 2 months, and I figured it out the albedo sections. But for the temperature, I'm not getting the accurate. Not accurate value. Ma'am, can you suggest me something?
What I have not worked on this too much, but what little knowledge I have is through MODIS data, you can measure the snow temperature, snow surface temperature based on the MODIS data. Otherwise, you can get back to me. I have the email mentioned, and Dr. Somnath Saha will also help you get in contact with me. Then I can help you personally, whatever data you have.
Okay, ma'am. Okay.
Thank you.
Okay, here, next, continue.
Any more
Dr.
questions?
Somnath, am I audible?
Yes, sir. Yes, sir.
Sorry for late joining because I have another meeting, and thank you, Bajpai ma'am, for your wonderful presentation. And on behalf of South Asian Institute, our institute SAIARD, I heartily welcome you and also Professor Ijan Bhakta, Professor Ram Avtar for giving their today's consent to participate of this event. And actually, we are actually celebrating today the 120th birth anniversary of Professor S.P Chatterjee, Padma Bhushan. He was the founder of National Atlas and Thematic Mapping Organization, as well as the Department of Geography of Calcutta University. So, and for this occasion, every year we are doing this kind of dialogue sessions on different scientific issues. And for that, I heartily welcome and thanks to all of you for joining with us. I will not continue my points, but just mention 2 points that from the very beginning we are associated with the national and international bodies for doing such kind of dialogue activities, research collaborations, and all that. And in this respect, we have already signed recently an MOU with the Kathmandu University for doing such kind of research and project collaboration. So I will be happy if your university and you can also associate through that research collaboration mode, and on that basis we can do something for the betterment of our society. So with this I conclude, and I will thanks to our convener Somnath as well for such a wonderful initiative regarding the organizing of such kind of event. So thank you to all, And thank you, Ria, for
Thank you to all, sir.
Thank you, ma'am, once
Okay.
again.
Okay. Okay.
Ma'am,
Yeah, please
can
continue.
you please, can you please share your email address?
Yeah, sure.
It is vanyabajpai@gmail.com.
Ma'am, kindly type it in the chat box.
I'll do that. Dr.
Yeah,
Somnath,
sure,
you can
sure.
mention it, please.
Yeah, sure. Okay.
Thank you, Bishojit sir, for joining us. Now I would ask Professor Ram Avtar to please present your presentation.
Hello. Here, Professor Rijan Bhakta has joined. Hello.
Yes,
Hello.
sir. Finished.
Professor Rijan Bhakta has joined.
Sir, he is busy right now, so that he is leaving for office work. So we will connecting with email or WhatsApp if we have any queries regarding this.
Professor Rijan Bhakta has
Sir,
joined.
yes, he has already delivered his lecture and he had to leave because he has some prior commitments.
Okay. Thank you. Fine. Please continue.
Professor Ram Avtar, if you would please deliver your lecture. Thank you.
Yes, hello. Yeah, can you hear me?
Yes, sir, you're audible.
Thank you, Dr. Vijit Rai, for the invitation. And I think my previous resource person, Professor Kayastha and Professor Bajpai, has well covered the facts about the glaciers and how we can use the geospatial data. Today in this lecture, I will cover a little bit different. The topic on or the title of this talk is the role of especially the advanced geospatial techniques in Arctic studies. So my name is Ramavtar. Let me briefly introduce myself. I'm currently working here at Hokkaido University. And today I will cover these 2 or 3 case studies, whatever time allows. I think I have about 15 minutes. So I will try to cover either 2 or 3 case studies, whatever is possible today. So let me briefly introduce myself and about the Global Land Program, because I'm the director of Global Land Program, Nodal Office, Japan. So, and I have divided this talk into 3 parts. First one about some of the activities of JLP, because some of you are coming from the geography or environmental science field. So if you are interested, then you can also join this Global Land Program community. And then later on, I will cover some of the case studies related to how we can use the interferometric SAR kind of advanced remote sensing techniques for monitoring the permafrost region, followed by how we can use the advanced machine learning techniques for monitoring the coastal plain lakes, especially in the Arctic region. And the last one is how we can monitor the drift ice that is coming from the Russian part towards Japan using the advanced LiDAR data. And the last one, because the topic, because in the beginning I was thinking to cover this impacts of climate change on Himalayan glaciers. I was thinking to cover this, but this is well covered by Professor Kayastha and Professor Bajpai, so I'm not going to touch upon this topic. So let me briefly introduce myself. I'm basically working in the field of remote sensing applications in the Global Land Program, focusing on how we can use the geospatial data for land management, land use, land cover monitoring, biodiversity ecosystem services, as well as how we can use the geospatial data for sustainable development goals. And basically, I'm from India, and I have completed my master's and MPhil from Jawaharlal Nehru University, and I did my PhD from University of Tokyo, Japan. And I have been working with various institutions around the world. I worked at German Aerospace Agency in Germany, followed by United Nations University in Tokyo, and currently I'm working at Hokkaido University. So what is GLP and what is the GLP activities? So basically, when we talk about, I would be happy to kindly introduce briefly about the GLP and related activities, because I'm the currently director of the GLP Nodal Office Japan. So it's a kind of interdisciplinary community of science and practice that foster to study about the land system and co-design the solutions for the global sustainability. So there are various offices around the world. So one of the offices in the Global Land Program Sapporo Nodal Office, and this was established in 2006. And we have been mainly focusing on or promoting the various kind of collaborative and coordinated activities as a part of sustainability science, vulnerability, and resilience. And in 2016, we have started this consortium of the several universities in Japan. So there are various universities in Japan that is part of this GLP Nodal Office Japan consortium. And we have been conducting various activities around the world. And these are some of the activities that we recently conducted. So we are basically actively involved in the global land program, and we are doing the activities that can outreach and disseminate the scientific knowledge in Asian region. Some of the recent activities that we had recently conducted in 2022, we had conducted some of the hands-on training, especially how we can use the drone or UAV data for precision agriculture that we conducted in Malaysia. And we are going to conduct our next upcoming the drone applications in precision agriculture in Indonesia and Malaysia, in Indonesia and Vietnam next month. So if you are interested some of the work related to the GLP activities, please go through this Facebook page and please like it, and you can also be part of this GLP community, and you might get many information related to lens system science. And these are some of the conferences we organized in Sapporo in 2021 as a part of the GLP Asia conference. And recently, in December 2022, we had organized the Sustainable Mountain Development Conference in Nepal. So that time we had an opportunity to discuss with about the sustainability of mountains, because this year we are celebrating the mountain year. So we organized this activity, and that time there were many resource persons and the professors and scientists that joined this conference in Chandragiri, Nepal. I think Professor Kayastha was also there, and some other professors were also present there. So this is about the very brief about the GLP related activities. So if you are interested, please join this GLP GLP group, and I hope you will be able to get some more updated information about the research related to land system science. Now I would like to start my first of the case studies that I briefly mentioned. So the title of this study is how we can use interferometric SAR techniques for monitoring and analysis of the thermokarst or permafrost region in the Mongolian region of the Siberian permafrost area. So basically in this study, we are using the synthetic aperture radar based technology. So, and we are using the concept of interferometric SAR techniques. To use these techniques, we are trying to monitor what is the displacement, or if there is some sinking is going on, if there is some permafrost is melting, then if there is the lakes are coming up. So those kind of some of the activities we are applying this interferometric SAR techniques. So INSAR basically is a form of the radar sensing technique that is used to have 2 or 3 dimensional information about some of the objects. So basically when we use the concept of INSAR, we use either 2 or more than 2 SAR images of a particular area, and we try to identify if there is any surface motion is there along with the time, whether there is any displacement. Recently, you might have heard this Jyotimath. There is especially in India, the Himalayan part of Uttarakhand, that there is this land subsidences are happening. So people are using the interferometric SAR data to see what is the displacement. We can monitor up to in the centimeter scale. So therefore, that is the beauty about this interferometric SAR techniques, that can give us the information about the displacement, or if there is some landform is changing, then what kind of changes are happening. So the use of the second advantage, if we are using the center aperture radar data, then it's cloud-free data. We can use any time of the day, and they have, of course, like if there is a high soil moisture content, then they have some sensitivity. So we have to avoid that. Otherwise, we consider these SAR data set, they are the all day, all weather type of data, and they provide, especially the recent, the TandemX, TerraSAR-X, or the PALSAR data, they have very high resolution data set, and they have the good penetration capability of cloud. So we are going to get the cloud-free data set. So we have applied this interparametric SAR techniques. So how this interparametric SAR techniques work? So this is the, for example, this is the SAR satellite at one time, and this is the second time. Then you can see these fringes are there. Okay, so there is, based on this, the phase difference, based on this phase difference, we can identify if there is any displacement or is there any change in or deformation going on, and we can produce this interferometric SAR deformation map. We can produce using this multi-temporal SAR data, and based on this value, this formula, we can estimate what is the total displacement with respect to the time. So this is the basic concept about the INSAR techniques and the displacement. So basically, we applied this in interferometric SAR techniques in Mongolian permafrost region. So basically, what is permafrost? Permafrost is the ground or the soil or rock that remains at 0 or below 0 temperature for at least 2 consecutive years. So that is called permafrost. And what is thermokarst? Thermokarst is the process by which the characteristics landforms results from either the thawing or the ice-rich permafrost or the melting of the massive ice. So this is the whole process, we call it thermokarst process. So what is happening, as we have seen, like the cases of the climate change is going on, and there are various causes of climate change, anthropogenic as well as the natural causes are there. So if there is the climate change is happening, then what is happening in case of this permafrost region of Mongolia or Siberian Mongolia? There are these permafrost regions, they are melting. If they are melting, then there is also formation of these permafrost lakes is happening, and there is also the land deformation is there, land subsidence is there. So basically, we applied this interferometric SAR techniques to see if we can monitor the land displacement or if there is any thermokarst leakage coming or not. So, and because this process of the thermokarst formation is accelerating with the increase in temperature, so it's very important to use the geospatial techniques. So basically, we need to, because it's quite difficult to do the ground survey or collect the ground data. So therefore, that shows the importance of the interferometric SAR techniques that we can apply, and we can access some reliable information that can be useful for monitoring or for making some kind of management and bringing some policies that can reduce this degradation of the permafrost in this region. So this is the study area, study site that is part of the Mongolia, and it is located in the southern fringe of Siberian permafrost. Basically, there are 3 sites that we had selected: the Darkad, Chulut, and Galut. So these are the 3 sites that we had selected for this study, and they have the different kind of permafrost extent, because in case of Darkad, there is continuous permafrost that is present there, but in case of Chulut and Galat, they have the sporadic and discontinuous permafrost region. So therefore, we selected these 3 sites. And here you can see these are some of the Google Earth images that show the sites. Here you can see there are lots of these, the permafrost lakes are there that is forming there. And the lake area, you can clearly see how big it is by looking into this light blue color. Okay, so it is very important to see how what is the behavior of these lakes and whether there is increase or decrease in the number of lakes in these particular 3 sites. So here you can see there is a change in the thermokarst change in each year from 1962 to 2006 that has been done by some of the study. So especially in the site 1, there is an increase in the number of the lakes as well as the area, but Chilu, there is an area and number of lakes are decreasing. So we wanted to see what is the impacts of this temperature, precipitation, how it is, what is the impacts of these physical parameters on the permafrost. So to monitor that, we had collected the data from 2007 to 2016 using the PALSAR L-band synthetic aperture radar data of all these three sites, and we have done this interferometric SAR-based analysis. So here, these are some of the results that shows the displacement value. So finally, this is like for in case of Darkhat, we have the image of 2007, 2008, and this is 2009. We can produce and overlaid with this displacement map, and finally we got this is the displacement map of Darkhat region. Similarly, we also conducted the study for the next site, Chulut. So these are some of the displacement. And here we try to overlay what if the displacement is going on, then is there an increase or decrease in the number of this number of these permafrost lakes or not. So it is very important to look into the temporal scale. What kind of changes are happening, and what is the displacement. So finally, we got these are some of the basic results that we got that shows the displacement with respect to time in all these three sites. So we can clearly see some of the site is showing the significant high displacement, but as compared to other sites. So we recently published this paper in one of the land journal. If you are in the land degradation journal by Billy, so if you are interested, I will share with you later. Okay, so this is the first case study. Now let's move to the second case study as I have less time. So this is the second case study. We have been working on how we can model the Arctic coastal plain lakes depth using the machine learning and the Google Earth engine. So the motivation of this study, because in 2018 I visited the Yakuts, the Russian part of the Siberian part of the Russia. There is Yakutia, and then I have noticed there is lots of these the lakes are coming up, and people were not able to see what is the depth of these lakes, whether these are quite deep. So I start looking into if we can. I had some discussion with some of the scientists in Yakutia Research Institute, and we looked into some possibility how we can collaborate and work together so they can provide us some ground data, the ground-based bathymetric information, and I try to model those bathymetric information in satellite-based model, and finally I can predict the bathymetry of these lakes that is coming by the melting of these permafrost lakes. So the background of this study, there is numerous shallow thermokarst lake in Arctic coastal plain is recently shown a change in, and there is a lake abundance, and the area is also increasing. That is mainly because of the climate change or global warming. And these lakes and ponds can occupy more than 20 to 40% of the landscape in Arctic lowland regions. And the IPCC and other recent studies, they have clearly reported there is high latitude warming is much more higher than the global annual average warming. And one of the study by Gross that they have estimated the more than the half of the lakes found in permafrost region are likely to be the thermokarst in origin. It means by the melting of the permafrost region. If that is melting, it means there is more inflow of the water. So these lakes undergoes various phases of formation, growth, and drainage, and reformation that is happening in these lakes. So it is very important to study about these lakes. Therefore, monitoring of this lake that is present in the Arctic region at high spatiotemporal resolution is very crucial to understand how they are responding with respect to the climate change. To better understand the degradation of the lake bodies due to the climate change in Arctic environment, a comprehensive lake water volume analysis is needed. And to estimate what is the volume of the water, it is very important to estimate the bathymetry of the lake. So therefore, we had conducted this study. Although there is no quantitative bathymetric studies has been done so far, there is only very few limited ground data is available. So because the main reason is the logistic problems are there, and doing such kind of research in a very harsh climate is not possible. So therefore, there are very limited studies. So we try to look into how we can overcome this limitation by using the geospatial or remote sensing data, because remote sensing with the multi-spatiotemporal remote sensing data is available. So we can use simple the Landsat data or Sentinel data. Can we monitor the bathymetric information of these lakes? That kind of studies we have done. So this is the study site that is nearby Alaskan region. And we were lucky because there was some study by Simpson et al. They have measured these the bathymetric of the some of the lakes in this particular region using the sonar system that can give us the ground-based bathymetric information. If we don't have any such kind of information, that is quite difficult to conduct such kind of bathymetric studies. So we were quite lucky to get such kind of data from the data archive. So these are the specification of their sonar mission that they had conducted. And finally, we used this Google Earth Engine and machine learning algorithms and applied on using the Landsat data. We corrected the Landsat data, and finally we applied. This is the code. If you are interested, we can provide you. You can also apply and see if you are interested to monitor the bathymetry of the Arctic lakes. I can provide you the code, then you can use it. So finally, we got these results. So we applied we used different models like different machine learning models, decision-tree, random forest, and support vector machine, and we got different results. But still, then we compared what kind of machine learning algorithm is good for monitoring the bathymetry of this particular area. So for that, we did the accuracy assessment. So these are some of the results of the accuracy assessments. If you are interested to know more about this study, or if somebody is doing such kind of a study, I will be happy to support you. And we have also recently, last year, we published this paper in one of the journals. If you are interested, then I will send you the more detailed information about this particular study. Then the last one is the case study about drift ice monitoring in the Sea of Okhotsk in Japan. So what is happening from Russia? The drift ice is coming towards Japan, and because of the climate change, there is a lot of huge changes is happening. So we try to look into whether we can monitor the thickness of these the drift ice. So we did this LiDAR-based UAV monitoring. We conducted a LiDAR survey data. We collected the LiDAR data to monitor the thickness of the ice. So I can show you one of the video how this drift ice looks like. You can see this is one of the video that we made. So see, you can see these are the drift ice, and then icebreaker come and it passes through these drift ice. So here you can see there are different types of, some are smaller in size, some are having the high and much more thicker than others, and some are having the deposition of the snow. So we try to look into whether we can identify the shape, size, and texture of all these, and how we can classify and what is the thickness of these drift ice. So we conducted this drift ice survey using the LiDAR data in last year. This year we also conducted our survey, and we processed the data using not only the planet data, we also use some of the Sentinel-1, Sentinel-2 data, what is the movement. But these are some of the results that we got using the LiDAR data sets. So here you can see this is the orthomosaic of the drift ice that we prepare, and this is the 3D map using the LiDAR data. And finally, we produce the height where it is having the thick drift ice. So, and finally we got some results. So we are still preparing the results. So this finally we got some of this thickness map of this drift ice. This is simple RGB. This is thickness map. Yes. So these are some of the results that I just briefly shared with you. So I would like to stop my talk here because this last topic, importance of the Himalayan glaciers, that is well covered by Professor Bajpai and Professor Kayastha. So now, if you have any particular question or comments, you may ask.
Thank you, sir. Your presentation was wonderful. If anyone has any question, please raise your hand.
Yes, Professor Bajpai.
Ram Avtar sir, I would like to ask that the machine learning work which you did for those lakes, So can it be done for the Himalayan glacier lakes also, the same kind of work? Can it be applied there?
Yeah, it's possible, but the thing is, in case of Himalayan glacier, we don't have any very limited the ground-based bathymetric data. That is first limitation. Second is the terrain is completely different. In case of Arctic, it's quite flat, so we can easily apply. But in case of Himalayan terrain, it's very undulating and very high altitude mountains are there. So maybe could be a limitation, but still we can try.
Sir, if you can provide with the whatever paper you have published, so I
Yeah,
would like.
I can just send you.
Thank you so much, sir.
Also, sir, the code you use for distance learning programming, sir.
Yeah, that is available there, I think.
Any more questions? Okay, I would like to ask Professor Somnath Shah to please address us.
Okay, thank you. Good evening, everyone. It is such a great honor to be a part of this wonderful event. On behalf of this SAIARD and IIST, I'd like to extend my heartfelt gratitude to our esteemed guest, Dr. Rajiv Tandon Mahajan sir, Professor R.B. Kayastha sir, and Dr. Bajpai madam, and Professor Ramamata sir. Your valuable words on geospatial technology in glacial management. It has very insightful and very received by all the audience. So I must be thankful to our chairman sir and colleague Dr. Pratik Prasad Sahu sir and Akash and anchor here. First, without this support, this event was not successful. And lastly, thanks my audience, Dr. Jayant Gaur, Dr. Ranjit Kumar sir, and Region Bhakt Kayastha sir and Shubhandu Karmakar. So all of you, lastly, very much thanks to our students and audience for their patience. Thank you, all of you.
Thank you, Dr. Somnath, for having us. It was an honor to be there.
Thank you all for the incredible session. Now we'll be ending it. Thank you once again.